All right, this is screencast number 2 for Unit 3, Lesson 1. And we're talking about the atom. I'm on page 118. What are the parts of an atom? Well, if you notice, the blue model on these two pages represents an atom. This model of an atom shows where protons, neutrons, and electrons are found within the atom. Protons and neutrons are found in the center of the electron cloud, in what's known as the nucleus. The particles in this model are not shown in their correct proportions. If they were, the protons and neutrons would be too small to see. So this model isn't even drawn to scale. Okay, protons are the positively charged particles of atoms. The relative charge of a single proton is often written as +1 or 1 plus. The mass of a proton is very, very small, 1.7 times 10 to the negative 24 grams, or I don't even know how to say a number that small, but there it is. The masses of particles in an atom are so small that scientists made a new unit for them, the Unified Atomic Mass Unit. The mass of a proton is about 1 unit, or 1 AMU is what I'm used to referring to it as, atomic mass unit, 1 atomic mass unit. Okay. The reason why we did that is because it's not very helpful for us to protons in grams, because it would be such a small number that it's hard to get our mind around that small of a number. All right, neutrons. Neutrons are particles that have no electric charge. They are a little bit more massive than protons are, but the mass of a neutron is still very close to 1 U, or 1 AMU. Atoms usually have at least as many neutrons as they have protons. Together, protons and neutrons form the nucleus of the atom. The nucleus is located at the center of the atom. Okay? The model that they showed you on this page is a model of beryllium. This model of a beryllium atom shows that the nucleus of this atom is made up of 4 protons and 5 neutrons. Because each proton has a +1 charge, the overall charge of the nucleus is +4. So +4 because you have 4 protons. The volume of the nucleus is very small compared to the rest of the atom, but protons and neutrons are the most massive particles in the atom. So the nucleus is very dense. If it were possible to have a nucleus the volume of a grape, then the nucleus would have a mass greater than 9 million metric tons. Okay, I'm not super worried about you knowing that. But please just understand that protons and neutrons have almost all of the mass in an atom, and they are packed together in the nucleus of the atom. All right, then we have the electron cloud, which is that big blue area that's surrounding the nucleus. The negatively charged particles of the atom are called electrons. Electrons move around the nucleus very quickly. Scientists have found that it is not possible to determine both their exact positions and their speed at the same time. This is why we picture the electrons as being in an electron cloud around the nucleus, because you can't really pinpoint where they are at any particular moment. We just know they're in that area, in that electron cloud. Compared with protons and neutrons, electrons have very little mass. It takes more than 1,800 electrons to equal the mass of 1 proton. The mass of an electron is so small that it is usually thought of as almost 0 U, or remember, we're calling them AMU, okay? Almost 0 atomic mass units. The charge of a single electron is represented as a -1. The charges of protons and electrons are opposite but equal. The number of protons in a neutral atom equals the number of electrons. So the atom has a net or overall charge of 0. For example, the beryllium atom contains 4 electrons. The combined charge of the electron is a -4, but remember that the charge of the nucleus is +4 because of the 4 protons. So you have 4 protons plus 4 electrons, so it's like a +4 and then a -4, and overall that is 0. So the net charge of the atom is 0. An atom, however, can lose or gain electrons, and when this happens, we refer to the atom as an ion. An ion has a net charge that is not 0. And you're going to find as we do this unit that it is electrons being gained or lost that is the whole central idea behind chemical reactions. Okay? All right, I'm going to go back, and there's a whole lot of marking up that I want to do because I want to make several notes and make you guys aware of several things. And we're also going to take a look at number 11. Actually, we'll talk through it, and then I'll show you my notes. So on the part of the atom, we have proton. The other two parts of the atom are neutrons and electrons. So let's talk about protons. Protons are located in the nucleus. They have electric charge of +1, and they have a mass of about 1 AMU. A neutron is located in the nucleus also, has no electric charge, and has a mass of about 1 AMU. Down at the bottom, the electron is located in the electron cloud, has an electric charge of -1, and has a mass of almost 0 AMU, okay, or 1/1800th of an AMU, because it takes about a little over 1,800 electrons to equal the mass of a proton. Okay, so let me show you what all I've got in the way of notes, and you guys can get your paper all marked up. Okay, so I've got this all marked up. First of all, on page 118, notice that I pointed out that it's protons and neutrons that are located in the nucleus. Also, I made a note that almost all of an atom's mass is in the nucleus because protons and neutrons weigh or have a mass of about 1 AMU each. And remember that the electrons have almost no mass. Okay, so almost all of the mass of an atom is in the nucleus. Okay. Down at the bottom, I made another note about the nucleus. Only a very small part of an atom's volume is in the nucleus, but like I said, it has almost all of the mass of the atom. Okay. The blue heading at the top of page 118, it says, what are the parts of an atom? Remember, the two main parts are the nucleus and the electron cloud. Okay. I'm going to pause it one more time and highlight the things that I underlined to make it a little bit easier to see. Okay, so the highlights on page 118 under protons. Protons are the positively charged particles of atoms. The relative charge of a single proton is often written as 1 plus or +1. The mass of a proton is about 1 AMU. Neutrons are particles that have no electric charge. Together, protons and neutrons form the nucleus of an atom. The nucleus is located at the center of an atom. Down at the bottom, the volume of the nucleus is very small compared to the rest of the atom, but protons and neutrons are the most massive particles in the atom. Remember, so the nucleus contains most of the mass of the atom. All right, on page 119, under the electron cloud. First of all, I pointed out that almost all an atom's volume is in the electron cloud. Okay, the negatively charged particles of the atom are called electrons. Electrons move around the nucleus very quickly. Scientists have found that it's not possible to determine both their exact position and speed at the same time. Compared with protons and neutrons, electrons have very little mass. It takes more than 1,800 electrons to equal the mass of one single proton. The charge, however, of a single electron is represented as -1. The charges of protons and electrons are opposite but equal. So even though they don't have the same amount of mass, the amount of charge that they both contain are equal. They're not the same charge, but it's the same amount of charge. So a +1 for protons and a -1 for electrons. Okay? The number of protons in a neutral atom equals the number of electrons. An atom can gain or lose electrons, however. When this happens, we refer to the atom as an ion. Ions have a net charge that's not 0. And just as a note, positive ions are known as cations, negative ions are known as anions. And if you think about it very carefully, cations are formed when we lose electrons because the atom is going to become out of balance and it's going to have more protons, which are positively charged, than electrons. If it's losing electrons, it's losing negatives, which means it's going to become positively charged. And if an atom is gaining electrons, then it's gaining negative charges and it's going to become a negative ion. All right, and then down at the bottom we see that the table has been filled in. Protons are found in the nucleus. They have a +1 charge and a mass of 1 AMU. Neutrons are found in the nucleus. They have no charge and their mass is approximately 1 AMU. The electrons are found in the electron cloud. They have a -1 charge and almost no mass, or about 1/1800th of an AMU.